2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. 1, 2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. Hey, math is so easy to me. It's so easy. Count it up like.
Hey everybody, today we are reviewing how to add and subtract fractions. Yes, this is something that we learned earlier in the year when we did Module 4. However, remember, we are reviewing fractions this week and next week because fractions are that awesome and they are that important to your success in the future for math. So you're going to notice that today, as we are solving these adding and subtracting problems, Ms. Rogers and I will be following these 5 steps. These 5 steps are going to stay on the screen the entire time that we are solving the problems. When you get to your independent practice later today, it might be helpful to go back to this video and pause the screen on these 5 steps so that you can refer to them as you are solving the problems on your own. So, without further ado, let's conquer our first adding and subtracting fractions problem. All right, let's take a look at our first problem. This particular problem is a subtraction problem. Step 1 tells me to convert mixed numbers to improper fractions. However, I don't have any mixed numbers, so I can move on to step 2, which tells me to find the LCM of my denominators. In this case, my denominators are 3 and 4. I'm going to start off by listing multiples of 3. I'll list the first 5. So 3, 6, 9, 12, 15. I'm going to stop there. I always like to list the first 5 as a starting point and move on to 4. The first multiple of 4 is 4, not a multiple of 3, so I need to keep going. Next I have 8, also not a multiple of 3, I need to keep going. The next multiple of 4 would be 12, and there we go. 12 is the lowest common multiple of 3 and 4. So I'm going to write that my LCM equals 12. All right, we've done step 2, let's move on to step 3. Step 3 tells us to use multiplication to make all denominators common. I'm going to start off with my fraction 2 over 3. Now, we need to use multiplication to make our denominator what we found is our LCM, to make it 12. So I take 3 and multiply it by 4 because 3 times 4 equals 12. Now, if you forgot that 3 times 4 equals 12, that's okay. You can use a calculator, you can use a multiplication chart to support you. Whatever I do to the denominator, I have to do to the numerator. So because I multiplied my denominator by 4, I also multiply my numerator by 4 to get 8 over 12. So instead of 2 over 3, I'm now going to rewrite this fraction as 8 over 12, okay? 2 over 3 is equivalent to 8 over 12, and I'm going to write that as I'm solving this problem. Now, I need to focus on my fraction 1 over 4, and following step 3, our denominators have to be common or the same. So my denominator for 1 over 4 has to become 12, and I'm going to use multiplication to do so. 4 multiplied by 3 equals 12. Again, use a calculator, use a multiplication chart to support you. Whatever I do to the denominator, I have to do to the numerator, so I'm left with 3 over 12. 1 over 4 is equivalent to 3 over 12. So instead of writing 1 over 4, I'll write 3 over 12. 1 over 4 is equivalent to 3 over 12. Now I move on to step 4. Step 4 tells me to add or subtract my numerators. In this case I'm subtracting, so 8 minus 3, which equals 5, and my denominator stays the same. Step 5 says to simplify or convert to a mixed number if necessary, but in this case we do not have an improper fraction, we cannot simplify, so our final answer is 5 over 12.
Hey guys, this is Miss Rogers. I hope you're having a fantastic day today. Today we're going to be adding fractions together. So the equation I have on my whiteboard is 3/8 plus 5/24. So the first step is we're going to convert mixed numbers to improper fractions. But if you look at this equation, we do not have a mixed number, so we can go ahead and just skip to step number 2. So step number 2 would be find the LCM of the denominators. All right, remember the denominators are that bottom number. So we're going to find the LCM of 8 and 24. So we're going to do this by listing out the multiples. So 8, 16, 24, 32, and I'm going to put dot, 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 because I could go on forever listing multiples of 8. Let's move on to 24. 24. Oh, I can stop because I already see a multiple they have in common. 24. So the LCM is 24. All right, step 3, we're going to use multiplication to make all denominators common. So we're going to make them all the same. So we want to change them both to 24 because we just found that that was our LCM. So 3/8 is the only one that needs to get changed because 5/24 already has that denominator. So 8 times what gives me 24? Now, if you don't know that on the top of your head, that's totally okay. You can use a calculator and do 24 divided by 8, and whatever that answer is what this number is going to be. So if you were to do that, or maybe you just know this off the top of your head, 8 times 3 gives us 24. Now, whatever you do to the denominator, you must do to the numerator, which is our top number. So 3 times 3 is 9. All right, so now that we changed both denominators to be 24, we have a new equation. 9 24ths plus 5 24ths. Now for step 4, we're going to add the numerators together, but we're going to leave the denominator the same. So our numerators are 9 plus 5, which gives us 14, and the denominator is 24. Now, looking at 14 over 24, I know right off the bat that is not simplified. And if you can simplify, you must simplify. So I'm going to give you a little hint. If you have two even numbers, so an even numerator and even denominator, if you don't know what to break it down by, you can at least break it down by 2. Because 2 goes into all the even numbers. So let's try that and see what happens. 14 divided by 2 is 7, and 24 divided by 2 is 12. Looking at 7 and 12, there is no number they have in common, so I know I cannot simplify it anymore. So our final answer is 7/12. So just to recap, we found the LCM of the denominators and got 24. And then we changed the denominators to be the same. So we did this with multiplication, and 8 times 3, we got 24. We did whatever we did on the bottom to the top, so 3 times 3 is 9. Our new equation was 9 24ths plus 5 24ths. Add those numerators, we got 14. Kept the denominators the same, so we still had 14 24ths, and we simplified it down to get 7/12. All right, I hope you guys have a fantastic rest of your day.
Okay, I know this is a long video, but we have one more example. It's a long video because Miss Rogers and I wanted to make sure that you had plenty of examples so that you are prepared to tackle your problems that you are going to do independently today. This problem has a mixed number, and this is our first problem in which we've had to convert the mixed number to the improper fraction. That's what step 1 tells us to do. So before I do anything, I'm just going to focus on my mixed number, which is 6 and 1 over 5, and I'm going to convert it to an improper fraction by taking my denominator, multiplying it by my whole number, and adding the numerator. Okay, 6 times 5 is 30, plus 1 equals 31. Okay, so that means that my new numerator is 31 and my denominator stays the same. So 6 and 1 over 5 is equivalent to 31 over 5. So I'm going to rewrite this problem as 31 over 5 plus 2 over 3. Now that we've converted the mixed number to an improper fraction, we've done step 1. Let's move on to step 2, which tells us to find the LCM of our denominators. Our denominators are 5 and 3. I'm going to start off by listing the multiples of 3. So I have 3, 6, 9, 12, 15. Those would be the first 5 multiples, so let me move on to 5. Okay, start with 5. 5 is not a multiple of 3, so I need to move on. Next comes 10. 10, also not a multiple of 3. 15, and there we go. 15 is the LCM of 3 and 5. So now I can move on to step 3. Step 3 tells me to use multiplication to make all denominators common. And in this case, we are going to make all denominators our LCM of 15. I'll start with 31 over 5. Now I need to figure out what am I going to multiply my denominator by in order to make it 15. And in this case, 5 times 3 equals 15. Whatever I do to the denominator, I must do to the numerator. Now I know we're dealing with a big number with the numerator, so use a calculator if necessary to support you. 31 times 3 equals 93. So now, instead of writing 31 over 5, I'm going to rewrite this as 93 over 15 because I wanted my denominator to be 15. And now we're going to focus our attention on 2 over 3. So we'll take 2 over 3, and again, we want our denominators to be common. We want them to both be 15. 3 times 5 equals 15. Whatever I do to the denominator, I must do to the numerator. 2 times 5 equals 10. So I now have 10 over 15, and I'll rewrite that here. Okay, so instead of 2 over 3, we have the equivalent fraction of 10 over 15. I move on to step 4 now, which is to add our numerators. So I have 103 over 15. Moving on to step 5, it tells us to simplify. Well, let me back up real quick. 15 is our denominator because our denominators always stay the same. Okay, now we can move on to step 5. Step 5 tells us to simplify. Well, 103 and 15 don't have any factors in common, so I can't simplify. However, this is an improper fraction, therefore I must convert it to a mixed number. I'm going to use this space right here to do so. So in order to go from an improper fraction to a mixed number, I take my numerator, 103, and divide it by my denominator. 15 goes into 103 6 times. Remember, you can use a calculator to support you. 9 times 15 is 90, which would give me a remainder of 13. From here, I can rewrite this as a mixed number. 103 over 15 is equal to 6. This is the number of my quotient. It becomes my whole number. And 13, remember my remainder becomes my numerator, over 15. My denominator stays the same. And this is my final answer. All right, time to get your independent practice. Remember to use this video to help you. Reach out to your teachers if you get stuck. Happy problem solving.
1, 2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. 1, 2, 3, 4, 5, 6, 7, 8. I love